So, Defin episode number 43 with Alexander Yakushev. This is Vijay from Holland.
Ray from Belgium.
And Alex, where are you sitting right now?
Oh, sorry, I'm having echo right now.
Oh, crap.
Oh, okay. Is it Alexa?
That's how we start.
What is it? Yeah.
Okay, yeah, I think I started. I sorted this out. Yeah, sorry about that.
No?
I'm in Kiev. I'm based in Kiev, Ukraine. So that's where I am from, and I'm glad to be here.
Yeah, actually, Alex, I never really noticed this before, but I was going to make a joke actually, but it turns out to be kind of true that your surname is basically Yakushev.
Yep.
Is that a joke already, or is that
Yeah, if it is, I don't get it yet.
You don't get it.
You have to explain it to me.
I haven't got long enough, but
but I referring to the Yakushevian part of the surname.
I am, yes, yeah. Sorry, it's an absolutely disgusting, terrible joke. So we'll move on.
You get one per episode.
Yeah,
Only one. Okay, so let's get started. I think, first of all, we'd like to thank our patrons who have been supporting us, and we just crossed 25, which is 26 right now. So officially, we are over quarter century of supporters for Defin, which is amazing.
Yeah, actually, it's catching up with the episode numbers. I don't know what happens when that, if we get to if the number of supporters overtake the number of episodes, I don't know if we all die or something, but let's hope not. I've got a few names, actually, I'd like to give a shout out to, if that's possible.
Yes, please.
Yeah. So, first of all, in the roll call, yay, is Fed Reggiardo. Thank you very much, Fed. We've talked to you on Patreon as well. You've been a stalwart supporter. Thank you very much. Next up is Donald Blale. Thank you very much, Donald. It's really good. And Jeremy Field is next. Thank you, Jeremy. I really appreciate it. And last is Alan, but with no surname. But he's at coopsource.org, so that sounds good. Right, so thank you very much, all of you guys and girls and all the people that are in between, up and down, whatever you're doing. If you support us, you're awesome. Even if you don't, you're still pretty good. You like Clojure. You're listening to this stuff non-accidentally. So thank you very much. We really appreciate it. Cheers.
Great. So let's get into the episode. Alex, can you please give a small introduction of yourself? Where do you work? What is your relationship with Clojure?
Is it intimate, Alex?
Yes.
Yeah, sure. I can start. So I work here in Kiev at a company called Grammarly. And I work as a backend engineer there, doing the backend stuff, a little bit of front end too, some NLP and that sort of thing. And I've been using Clojure for 8 years or something like that. So I guess it's pretty intimate by this point.
Yeah, well, it's so intimate that you're involved in the backend. But moving on, Vijay.
So, of course, one of the things that you've been talking about a lot, or at least you're maintaining the blog called Clojure Goes Fast. So you seem to be obsessed with performance, about Clojure and JVM stuff. So can you give us some background about what is your opinion about Clojure performance, and can it really go fast? Or if it is going fast, how fast is it?
Okay, yeah, obsessed is the good word. Probably not even a strong one in this case. But yeah, I've been caring a lot about performance on the JVM for Clojure, specifically for the past year or so, and that's comes mostly from the work I'm doing, because the loads we have to deal with, like the amount of processing our servers have to do is quite substantial, and it's like when doing web services stuff, any computational problem is at least big O of n problem, right? So it's like even if your algorithm is just works in constant time, but you still have to chug some amount of them for every user that uses your service, your server, that kind of thing. So the performance part, at some point, it becomes important for different reasons. And even though the computers are getting faster and faster, most of the time we don't get to see that too much, just because software is always can always eat away that extra performance year after year, so that the experience remains pretty much the same. Well, at least that's for that desktop software, for the user-facing software. On the servers, the situation is a bit better. So the better hardware we get allows us to process more requests, to handle more users. But it's still important to know what you're doing, to know how the underlying things work, to be able to extract all the performance from the hardware.
Quick question for you, actually, on that. In your use case, is your website, what kind of portion of your website is kind of dynamic versus, can be cached? How much can you do in terms of performance outside of the fundamental processing of forms or evaling Clojure code? Because that's those are the obvious easy wins, aren't they? To cache things and to CDN them and to make things static or memorize them or whatever. So how much of that kind of stuff are you involved in doing versus, oh no, we really have to have everything live all the time?
Okay, so the thing you're talking about is mostly the websites thing, and what I work on is more. So I work mostly on the NLP team. So what we do is we process user text to find errors in them or some possibility for improvement of that text, and that involves processing text in real time, extracting semantics from it, extracting grammatical structures and checking them if they're correct, comparing them to some baseline, and then coming up with some suggestions for how to improve that. And basically there isn't much that you can cache there on the high level. Of course, there are different caches on different levels under the hood, but it's not something that you can compute once and then just return to any amount of users, regardless of how many you have.
And how long have you been working at Grammarly with Clojure?
So I've been working for 3 years now, and I think I started using Clojure there right from the start. Just the intensity of it was changing over time. But apart from Clojure, we also use quite a lot of Common Lisp and Java as well. So I've been writing some Common Lisp there too, and Java.
Okay, and before we get more deeper into Grammarly stuff or the work that you're doing right now, so what was the journey before Clojure, and how did you hear about Clojure? How did you get into this?
Okay, my story, I think it's quite an ordinary one. For some people can recognize themselves in that, but I started programming when I was 12, I think, and it all started with Pascal and Delphi, and I was doing some competitive programming, like algorithmic stuff, that kind of thing. Yeah. And looking back at it, I think I wouldn't even call that programming, because so I knew algorithms. I could come up with a way to solve the artificial task that was mostly what
was it like top coder or something?
Yes, some sort of it, but just not online. Yeah. It was on the school level and college level, and so yeah, my programs worked and they could solve the task, but I mean, I didn't use functions, I didn't use procedures back at the time, so it was just one large blob of code, and I didn't use indentation back then. And
why would you?
Yeah, of course.
This is the first time I'm hearing I didn't use indentation. It's like a feature of a language or something. Yeah, I think indentation is a nice feature and it's interesting.
Yeah, and it was in Pascal, so you had to define all the variables upfront the procedure. And since I didn't use any procedures, it was just one big begin end kind of program. So I had this block of 20, 30 variables with different names on top. Yeah, it was fun. But anyway, when I went to university, they taught us Java there, so I switched to Java, and that was kind of like mind opener kind of thing. How programming actually works, all the
Like
abstractions.
indentation. Oh my god.
Yeah. So
Yeah.
actually, they forced us to indent our programs, and I still had like this very strong opinion about that. So what I did instead, I used Pascal to write an auto indenter for Pascal code, just so that I don't have to indent that manually. Yeah, I didn't know about good editors or IDEs back then too. But
So
anyway,
in the tabs and spaces war, you're just nothing.
yeah,
Nothing.
Yeah, absolutely.
Yeah, it's nothing.
Zero with space.
You've introduced a new category now. That's totally awesome.
It's much better than two-party system, right? We need to have for this one. Tabs or spaces, none.
Yeah, it's a false dichotomy, right?
Awesome. Okay.
Yeah.
Sorry.
Yeah. So anyway, Java was fun to me back then, but quite quickly I started looking at some other things because like everybody in our group was learning Java, using Java, and wanted to try something else just to stand out of the crowd. And I looked at Ruby, and that also interested me a lot because it was very different from what I seen before, what I learned before. It was very easy, like to write these small programs, and I learned about regular expressions. That was also like a mind-blowing thing. And then somehow, I think somewhere on the forum, someone wrote about this weird Lisp thing, which is like the best language ever, and everyone else who doesn't write Lisp is like missing out totally. So I looked that up. I downloaded the thing. I think it was called Lisp Box. So it was an Emacs with Lisp with Common Lisp bundled together. So I managed to install that on Windows, and
wow.
Yeah, back then I was using Windows, and it actually worked for some definition of work. But also found out the book, the GigaMonkeys book, the Peter Siebel book, I think, Practical Common Lisp, and like the first chapters, they were totally mind blowing. I mean, the second chapter is where you get to implement a SQL-like language inside Lisp. Back like then, I understood that I certainly was missing out on something, and it's like the programming can be absolutely different. Then quickly I discovered Sick book, so I tried Common Lisp for a bit, then played with Scheme a little bit too. But then so the assignments we had at the university, we had to do some graphical stuff. I mean, like you have to write a program, but then you have to make some sort of user interface for it. And because there were not many options doing that in Common Lisp or in Scheme, so I had to do that in Java. And at some point I decided to look something like, is there a Lisp for the JVM? And after a bit of like Googling on some evening, I actually find a few. There is this Kava thing, which is like Scheme on the JVM, and there is ABCL, which is Common Lisp on the JVM. And there are a few others, but I also found Clojure, and Clojure, I think it had the most professionally done website of the most amateurish websites for the languages. And I think that at that point I made my mind about what I should try next, and
So basically, you're saying that the level of professionalism and welcomeness of the Clojure website got you going. I mean, I'm pretty sure it's going to be a retweet from Stuart Holloway or Alex Miller.
I think at that time it was on the PB Wiki or something, right? It's like the website was not actually like this at that time. It was built by Rich's brother, and the website was a PB Wiki shitty thingy somewhere. It's basically a wiki website.
Yeah, it could be. It was 2010.
2009 or something.
No, so I found it in 2010. Maybe by then it was actually Actually, the website we have, not the one right now, but it's like just
No,
the
the
white
previous
thing.
one.
Yeah.
Yeah.
Okay.
Yeah, yeah.
That
It
was
was
probably the one.
based on a PB wiki thingy, I think.
Mm.
I don't remember exactly. It's called Peanut Butter Wiki or was some of those things. And anyway, good times. It was a long time ago. Okay, cool. So that's how you got into Clojure. So what kind of stack are you using right now? Because I know we spoke a bit about your work when you were here for the Dutch Clojure Day 2018, which is I think 9 months ago, I suppose. Um, so you are working on uh, maybe a quick idea about what your product does. That helps people to put some mental model of Grammarly.
Yeah, again, as I was telling, Grammarly improves. It's like the text writing assistant, and it checks for errors in writing and suggests improvements in grammar and style and other areas. And we have a big team of computational linguists and researchers who are skilled in linguistics and in natural language processing, and they come up with different algorithms and kind of like programs to do all that stuff. And my role, and the role of my small team, is basically to give them the instruments to do that. So that involves giving some sort of platform where they can develop
Yeah.
their algorithms, their code, and then at the same time, it's a platform to ship those features, those algorithms to the end users. And yeah, that's what I'm mostly working on. And then at the same time, once those are shipped, I'm responsible for maintaining that, running that in production.
So
Cool.
do you have an NL? Do you have a DSL then for your scientists?
Yeah, actually we have, and it's written in Common Lisp right now, most of it.
Okay.
But there are some plans to move some of that to Clojure as well.
Nice. It's a fantastic product, by the way. I'm a happy customer, so I've been using it for a long time now, especially for my writing my all my MBA assignments and all that shit. Like it's really nice to switch between formal language, and it's really fast. I really like it. Uh, anyway, this is not about Grammarly doesn't sponsor us, but I'm just saying it's a nice it's a very nice product, and I've seen so many people using it already. I think there is already a free version that you can use without any restrictions or something. Anyway, so but is it only English, or do you plan to go to other languages as well?
Yeah, first, thanks for the compliments, but and yeah, it's only English right now, and there are no hard plans to move to other languages yet, and mostly that's because every natural language is like they're so much different,
Yeah,
and it's like the the stuff that we learned for English and like the work that we already have done for the English language doesn't actually help much in moving such product to other languages. You actually have
yeah.
to redo it mostly from scratch, and that's like both for the programming part and for the just domain language part as well. Like it's
Mm.
totally different knowledge and totally different pipeline, and yeah, it's quite hard to come up with a new language in a product like that.
But how did Grammarly pick Clojure, or why?
Uh, I think that's mostly because of me.
That's nice. Yeah.
Yeah, at Grammarly, it's only our team uses Clojure, so it's not a completely Clojure based
Okay.
company, and people use Java as well and Scala, and of course the front end teams are doing their front end things, and yeah, so there is no Clojure script, something like that on the front
But
end in other
how are
teams.
you able to sell Clojure to them?
Well, since the team that I've ended up in used Common Lisp already, so I think think that's even a bigger evil, a harder thing to sell. But that also happened historically.
Was that your opening pitch? Common Lisp, it's a much bigger evil than the one I'm offering.
We'll pick lesser evil.
We've got a lesser evil. I mean, interesting pitch, It's
yeah, but the common Lisp system is quite old already. Old in terms of it's not outdated. We're actively working on it, but I mean it's been around for quite a lot of time at Grammarly, and so historically Lisps are quite popular at AI stuff, language processing as well, for different reasons. A bit for historical reasons, because the first wave of AI happened to coincide with the times when Lisp was developed, were actively used and popular, and it's not, unfortunately, it's not like that anymore. But some people are still carrying the flag, so to say.
Yeah.
Yeah, but Lisp works quite well for a lot of reasons in this task. And Common Lisp itself is a great language, and it's a language that lacks a good runtime, a runtime like JVM, for example. But the language itself is actually spectacular, and the environment that you can build with it, and this interactive live thing that you can then give to your domain specialists, and they can work with it, and you can evolve it, you can improve it, you can develop custom things for them, and they can use it without doing those recompilations and restarts and reloads. It's like developing a product and an IDE at the same time. So that's when I describe our Lisp system to other people. That's what I usually say. It's like without it, we'd have to develop two separate things, like a production system and an IDE to develop it. And basically, we cut the development times by half.
Yeah, that's a really nice pitch. And so I'm assuming it's Emacs everywhere for you.
Yeah, absolutely.
Of course. Yeah.
Well, for Common Lisp, there are not a lot of options. There are a few commercial ones, as far as I know, but I don't know if anyone at Grammarly has ever tried them. Well, I certainly didn't, but Emacs plus Slime works quite well for us.
Nice. So, because you have experience in Common Lisp as well, how do you contrast it with Clojure?
Common Lisp is certainly much more holistic in the meaning that it's a thing in itself. It was designed from the ground up to be a Lisp, right? Because Clojure piggybacks a lot on the JVM, and that involves making some design decisions which are not like completely Lisp-like, so to say. For example, like the Common Lisp, it has a superior error handling system, and it's
there we go.
Yeah, that's where you're waiting for it.
No.
Yeah, but so error handling in Lisp, it's a lot different from regular languages, and the main thing about it is that it's similar to exceptions and like to catching exceptions. But when you do catch exceptions, you don't unwind the stack, and that means that the program is able to go back to the place where the failure occurred, and then it's like continue processing, continue going from that point. I can give an analogy that I like to tell. So imagine there is a factory, and there is a factory worker, let's call him John, and he's cutting bolts from the metal molds or something.
Mm-hmm.
And then he has a batch of 1,000 bolts to make, and then at the bolt 527th, something breaks. I don't know, the bolt that he was making, it got broken. And now this John guy, he has a few options. He can throw it away and then make another one when I'm making the replacement. He can throw it away and not make a replacement and produce a batch of 999 bolts, but then it's like the amount of source material will not be changed. Or maybe he can stop the production line, maybe he can do something else. So he has all the abilities to make a fix, but he doesn't know which one to do because he doesn't have the authority to decide, for example. So if it's a Java factory, then what he does is he throws away all of his batch, he shuts down the line, he goes to the
supervisor.
Yeah, he goes to the person responsible for the line and asks, like, what do I do with this bolt? And that person doesn't know, so he shuts down the whole building, and he goes to the director of the factory, and yeah, he powered out everything. Actually, he burned everything to the ground, and he goes to the director of the building, director of the factory, and says, like, what do I do with this bolt? And the director might have to say something about, yeah, okay, you have to replace it, or here is another bolt replacement for you. But then at that point, the John guy,
stop bothering me.
Yeah, he just quits his job, and the whole factory burned down, and now the director of the factory has to build a new one and hire all the new workers and start the production again. So that's how Java works, or Clojure. Or Clojure for that matter. But in something like Common Lisp, so the error handling is actually it's split into like the place of the error and the place of the decision making, and it's called the restarts and like condition handlers. And what it means basically is that the code underneath, it knows how to fix things, and the code on the top knows what decisions to make. And if something gets broken, then this error, it propagates to the top, and on the top, the code on the top says, okay, in case of a network failure, you have to restart, you have to try again. And then that failed code, it continues right from the place where it errored, and it means not burning the factory and building a new one. It can continue right from the same place. And actually, the error handling is also very closely tied with the debugger. So if there is no error handling code, and for example the network failed, then you get an exception. You get a stack trace in your Emacs. Hopefully, you're using Emacs, and
of course,
yeah. And what the programmer can do at that point, he can just click on the button saying like restart, retry that thing. It will not retry the whole operation that you've set it to do, but it will retry that little thing that failed and continue. And if there are already some state in the program, it will be retained. It will continue from the failing point.
That sort of reminds me of when Windows gets a problem and asks you to debug it. Yeah.
Emacs does that too.
Yeah, they are both operating systems, right? So there is some similarity.
But do you think this is like because you dig a lot into JVM internals as well with your investigation for the performance, do you think this is something that can be built, like the effect system or the restart system can be built into Clojure? Is it easy?
Yeah,
or is it simple?
Yeah, it's a bit of both, but it is possible to build something like that on top of what Clojure already offers. Actually, you don't need much more than just dynamic variables, because that's what underneath it uses some just stack, putting things on the call stack and then being able to look them up. And I have a small library. It's called Perseverance. It's in the Grammarly repository, and it actually implements something like that just for doing the retry logic, to be able to split the place where the error can happen and where you want something to be retried, to separate it from the place where you want to decide what to do. But to be able to do that for the general case on the JVM, I think that would be close to impossible, just because JVM does different design decisions in that regard. Because Common Lisp stack is more heavyweight, So by the point something happened, something errored, nothing is thrown out, everything is retained. So you can actually look the local variables on the stack, like on each stack frame. That's very convenient, but then it brings a lot of overhead as well. So if you want to write a classic Java program that throws an exception 1,000 times per second, which every Java program does, right? Then you probably would not be able to do that with something as heavyweight as common Lisp exceptions.
Okay. And because the other thing that I was wondering about is because you're digging deeper into Clojure's performance, are there any surprises or some things that you found out that, okay, this should be better, or this is the reason why it is getting slow? Or is it slow?
Yeah, so the thing about Clojure performance, and I think it's by design, and I'm quite happy about that. That Clojure always leaves it's like a leeway if you need better performance for that particular thing. If you want that thing to be faster than it is by default, there is a way to do that. So Clojure most of the time doesn't make some hard choices like, okay, this is gonna be slow because we want this to be convenient, something like that. It comes to many places, like to immutability, because you can opt out of it. It comes to the dispatch, so you can use interop anytime to call into Java. You can use unsafe math if the safe math doesn't satisfy you, and so for many such cases, you can still drop down to the raw thing, at least raw in the JVM sense, and use it. So I cannot say that there were some surprises where I found out that Clojure does something slower than it should, because I think it's just most of the time it's not a problem, because I don't concentrate on that much and I just use the faster thing where possible. Yeah.
What about the the classic Lisp sort of scheme things that that the JVM doesn't have, like tail call recursion?
Tail call optimization, you mean? Yeah.
Sorry, tail call optimization. Yeah, for recursion. Yeah.
Yeah. Well, in my practice, that never becomes a problem, actually, because for just recursive algorithms, you can do a loop recur thing, or again, it's like there are different ways to write it, and as a generic optimization, where you do the tail call optimization all the time so that you can elide the stacks and it suddenly becomes faster. That optimization actually comes with a trade-off, because suddenly you don't have the stack. So if something blows in your face, then you cannot look up like what were the steps that your program did to arrive at this point. So I think there is a trade-off there, and JVM, for example, it does a lot of different optimizations to improve the performance for such cases without taking the trade-off of the TCO. So yeah.
And what kind of tools do you use to measure these things? Of course, there is Visual VM and a couple of other tools that you get, JTrace and all that stuff that you get with the JDK. But with Clojure stuff, do you use anything different than that?
Yeah, so again, the beauty of Clojure in this case is that anything that works for the JVM applies to Clojure perfectly, and that's one of the reasons why I keep using Clojure. Because if you take something else, if you take something new or something not as well supported as the JVM, then you most of the time have to dig through some half-finished attempts to have the functionality that is available for the JVM readily, and a lot of people maintain it, a lot of people work on it, and we have access to that just for free, just because we stay on the JVM. So the tools I use, yeah, you mentioned Visual VM. It's a nice tool, but it's quite limited in its functionality. So I wrote a few libraries. We might link on the show notes. So there is a profiler, and also tools to measure the memory usage, both for the objects, also recently did a thing to measure the allocation rate for the current JVM process. And then there are also some even lower level tools like perf tools from Brandon Gregg, which not really JVM focused, but it's there for system level debugging, system level profiling, and benchmarking. But they can become quite helpful as well. There is also a set of Unix tools like the generic VMstat and IOStat and all those tools that many people use. And I know what else. But yeah, there is just a bunch of them, and you can collect your tool belt and start using it without having to write them yourself, or just spending a lot of time checking what works and what doesn't.
Well, what about because there are some commercial things, aren't there? Also like UKit and stuff like that, which will give you profile information on the JVM as well, kind of a runtime, and give you like causes of memory leaks and things like that. So, there are some kind of like commercial toolkits like that as well.
Yeah, there are some. I haven't used them too much. I think I have tried YourKit maybe once or twice, but recently, regarding profilers specifically, there is like a boon of good free profilers. There is this async profiler, which is I think the best that JVM has right now, and it's kind of predecessor, the honest profiler. So there are a few of them. They are quite lightweight and suitable to be used in production as well as in development, and they give this new alternative ways to render the results using the flame graphs, and which are quite intuitive and portable as well. So I think the commercial profilers can still offer something that's more than is available in the free ones. But in my work, the free ones are often enough.
Do you use any profiling in the production code? Because recently I started using Tuft library from Peter Tausanis, the library that basically measures at runtime. There is a macro that you use that is going to collect all the invocations, and it will give like the list of the performance detail of function calls or whatever, like a code blocks. I started using it. Do you use something like that?
Yeah, the Tufte, I think it's called. Is it pronounced Tuft?
Yeah,
okay,
Tuft.
Yes.
I don't know. I have no idea.
Yeah, neither do I.
I think it's based on Edward Tuft. I don't know, the visualization guy. It's based on his name, the professor. Anyway, yeah.
Yeah, so that library, I've tried it before. Actually, I think I used it once or twice. But there are these two ways to do the profiling, CPU profiling, for example, but it applies to others as well. So there are sampling profilers and there are instrumenting profilers. And instrumenting profilers, what they do is they modify, let's say, like every Java method. They put some special code at the beginning and at the end, so on the way in, on the way out, and that code basically measures the time, and it puts two timestamps, and so between the two timestamps you can get for how much time the method ran. And I think for Tufte you have to manually specify which functions you want to profile.
Yes, so you wrap the code block in a macro, and then there is a global level one. You can turn it on and off to make sure that the macro is running at the runtime.
Yeah, so it works for bigger chunks of code, like for longer running things. And
yes, of course.
If you don't instrument too many functions, then that could work. But in general, the instrumenting profilers, they bring a lot of overhead. For different reasons, because the code that is injected, it brings overhead. Then if you try to instrument smaller methods, it could lead to methods stopping being inline, so it disables some JVM optimizations. So there are some second order effects that the instrumenting profilers bring. And then the sampling profilers, they work differently. The idea basically you stop the execution of the JVM, let's say 100 times per second, and then you see what is on the call stack at that moment.
Okay, and then you compare with the
Yeah, and then you just build a statistical profile of what your program was doing all the time, and you render that, and that gives you an idea what is slower, what is faster. So it's kind of like less accurate, but actually the instrumenting profilers are also not very accurate because of all this changing of behavior that they do to your program. And the sampling profilers don't do that. So I actually prefer the second ones and the sampling profilers, and they also safer to be used in production as well.
Yeah, and sampling profiles are non-intrusive, as in you don't need to modify the code. You just monitor the program from external tooling. Right?
Yeah, right.
Okay, nice. So can you give us some idea about because you wrote a couple of other libraries already, right? With the to measure the memory, to measure the asynchronous profiler. Can you give us some idea about what those libraries are for?
Yeah, so let's start with the profiler. The CLJ async profiler is actually very small, very thin wrapper around async profiler, which I already mentioned. And what it gives you, it gives you the ability to start and stop the profiler, to run it for some amount of time, let's say for 10 seconds. And once it's done, it generates you this flame graph thing, which is interactive SVG file that you can open in your browser, and from there understand where your program spends most of the time. So it's a thin wrapper, but at the same time it gives you this interactivity in your Clojure program, which allows you to very rapidly check like what are the slowest part of the function you just wrote, or of the submodule you just wrote. And the experience it provides, at least to me, is very, very in line with what REPL provides in general. So it's like it took the industry to invent the whole methodology like called test-driven development, to start people writing small functions that you quickly check what they do without writing this huge system, and then just start it for the first time after half a year, right? So with test-driven development, people start doing something else, and in the Lisp community, it was there all along. Basically, like it was always like that. People were writing small functions. They were building bottom-up systems, and with performance measurements, with profiling or whatever else, it's very similar. So if it takes a lot of effort for you to see how your program is doing in terms of performance, then it's like if it takes a lot of effort, if you don't want to do it, then you will probably postpone it until the very last moment, where it's like your program takes 100 times slower than it's supposed to do. But if it's seamless, if it's very easy to do, and it's also quite entertaining and rewarding in some sense, then you will keep using it. It will just become the part of your workflow.
So where do you see, because this is all based on JVM, and recently there is a lot of noise around GraalVM. So where do you see this isn't it supposed to give us more performance benefits because it's going to be on the native code, essentially not running on top of the VM?
Yes, so the Graal thing, actually, one team in our company evaluates Graal for some other project right now. It's an interesting technology. I haven't looked into it too closely yet, but I think Graal works better for languages that did some trade-offs in the past, like for example JRuby, which tries to be more like Ruby, right? So it has these design decisions that were already made before JRuby came to life, and so that there are many things in terms of dispatch that are slower in JRuby and that Graal VM can optimize. And for Clojure, I think it's not there are not so many benefits that Clojure can reap from Graal VM, because Clojure already had some design decisions that made it already fast on the JVM.
I think it's mainly just the startup time, which seems to be a bit of a, I don't know why people are so obsessed by that, but.
Okay. So you're probably talking about substrate thing, which is like a part of the Graal VM package that allows you to natively compile Java program or Clojure program for that matter. That one is interesting actually, and the startup time for some kinds of applications, like for some user space tools, startup time
command
becomes
line tools,
command line tools. That can be important. And for that, this substrate thing is interesting, but there are quite a lot of limitations as well. So I'd be happy to check it in half a year or a year or so, when more people experiment with it and come up with something interesting.
Yeah. But like you say, it doesn't really help the REPL experience, because, that's something downstream. That's more tool chainy than, because, you can run things in the REPL with Graal, and the main advantage there, as far as I know, is that you can interoperate with R and Python and other languages. So it's this kind of polyglot aspect of the REPL that's interesting, isn't it?
Yeah, that's the one benefit. The other one is that, as far as I know, they have a completely different just-in-time compiler. So it's not the hotspot anymore. It's a JIT written in Java itself, and it's like some sort of fancy thing. It has its own optimizations, which are like more complicated and obscure. So it's an interesting.
But got to be better then.
Yeah, so we did some experiments, some rough experiments with the Graal VM, and turned out to be slower than the JVM for just a few tests that we ran. So we postponed that for now at least. But
talking of tests that you run, maybe it's coming back onto the main thing, is like if you're running the profiler and stuff like this, what do you do in terms of, because I used to do a lot of performance stuff as well, to be honest, and the biggest complication I think you have, apart from with the JVM especially, is you can get lots of misreads with just, if you just put a profiler on something in your development environment, you can get a lot of misreads versus your production code. Because actually, the JIT does all kinds of things to make things faster, and there's all this kind of warm-up activity on the JVM. So how do you kind of like, what's your philosophy around kind of guarding against those misreads?
Yeah, that's actually a very good question, because with performance optimizations and performance benchmarking and profiling, it's harder than doing just regular development work, in the sense that if you do an error in your program, then most of the time it will throw an exception or write incorrect data, or like do some other thing that will be apparent that it is broken, that it was wrong. But with performance stuff, you are never sure. It's like whatever you do, whatever you benchmark, whatever you compare against, you never know if you did it correctly, if you accounted for all the moving parts, if you if you did all the good work in there, or you just made some mistake and now you just reading garbage. So about the philosophy, there is this guy Alexei Shipilov, which is very vocal JVM performance. He blogger, and he has a blog, and he does a lot of conference talks about this topic. He also has a library called Java Micro Benchmarking Harness, which I use and also recommend to others, which simplifies some things in that regard, but at least it prevents you from doing some silly mistakes. and there are a lot of silly mistakes you can do when testing, like benchmarking performance. Because right, like you said, JVM does a lot of optimizations, and if you forget that it can do that in that case, then the results you're getting are just garbage. But his main philosophy about doing all those performance things is that numbers, they don't tell you anything. So until you interpreted those numbers, until you build a performance profile of the program in your head, and then you verify that profile, that performance model against some more experiments that otherwise should disprove your model, then you just did nothing. I mean, just raw numbers, they don't tell you anything. You should not use them as an argument, like if something is faster, if something is slower, something works better or not. Those are just data that you have to collect and interpret, and then make some like assumptions, and then prove them or disprove them. It's like that. So I agree with him totally in that regard. I try to work like that as well.
I mean, the one I always remember from the Java days was things like adding two strings, for example. You know, was a kind of classic. Oh, you shouldn't do that because it's slower. You know. And then it turned out that, well, it wasn't that slow for most cases. So shut up. It's actually it's easier to read the code where you just put a plus sign for a start, rather than all these string buffer type nonsense. And then B, it turns out that, you know, I think in 1.2 or 1.3, the JVM had an optimization for this anyway, and essentially rewrote your code. So, you know, you kind of like, every time that you change your code to kind of compensate for some performance issue, you're at risk actually of all that code, you know, the complexity of that code being wasted in the future, because in fact the JVM will just get better, and you know your code might in fact end up being slower because you're not taking advantage of the common case that the JVM people are optimizing for.
Yeah, that's true. So like most of the time, or like in general, the more abstract or the more general code you write, there will be bigger room for optimizations. And it's like, there are several phases of optimizing performance, right? So first, you try to get rid of all the stupid things that you wrote. Like if you
like code.
Yeah, like code. Getting rid of code always helps. That's the ultimate.
No code is really fast. Yeah.
Yeah, absolutely.
Exactly.
Yeah, but right. So you start with that until your code is perfect in that regard. So it's like it does what you intend to do, and it reads that way. But then if it's still not enough, then you start doing all those micro optimizations, and you you base them on the fact how things work right now, but in future they might work differently, and there is a trade-off there.
I mean, how much in your kind of work, like how many times do you think, or how much code do you feel like people genuinely have to shift around versus the kind of the feeling that, for instance, I mean, you know, okay, this is a weird question, long-winded question, but what I find in general is that people, the performance that people are suffering is just because they've kind of put a tight loop in the wrong place, or they've done something in a way that is just, there's nothing fancy you have to do with the language to make it better. It's mostly just about like understand, oh shit, yes, that's where the performance is. And now I just need to rewrite it and reorganize my code a bit more. So, you know, it's very, very rare in my experience that you actually have to, you know, go down to the kind of like micro code to see exactly how you should align your arrays, for instance. You know, it's like low latency Java people are doing amazing things in terms of, you know, in rewriting array buffers so they align to the hardware. But that's pretty rare in most cases, I think. Or I mean, do you find in Grammarly that you actually have to go along and like use those low latency tricks?
Yeah, so that again, that depends on the context, depends on what you're writing, right?
Yeah.
And sure, most of the time you don't get as fancy as just doing all those super micro optimizations for some very generic code for like some REST API or something. But yeah, I mean it. You get a bit of both, a bit of everything. At least I get that in my work. So sometimes it's just some stupid code that can be rewritten and it is suddenly just enough for the performance. And sometimes you see that, all right, everything looks as good as it could be, but then it still can be done faster. So we have to do something else. So yeah, I mean, people are bashing premature optimization a lot, and there was a nice tweet recently that those who like dislike premature optimizations probably haven't used any modern software, especially Slack, for example, which could use some premature or whatever optimization there could be. But anyway, I think this premature optimization thing is also quite helpful in the sense that people who do it, it might not be needed, but for example, for me, it takes to do that once on some project, like to do the optimization to see that it didn't work or it didn't deliver the thing that I expected for it, or maybe the performance was okay all along, but at least you learn something. So it's like this performance work is a combination of actually improving something and learning something new, learning the
Good point.
stuff underneath, so that the next time it comes up, you know what to do or you know what not to do, which is equally important. And regarding the question, we had a fun story actually on one of the services where the bottleneck was the number of network interrupts that the operating system could do on one core. So there is this optimization on Ubuntu that it will bag only all of the interrupts to one core on the CPU, because generally that's faster way to do it. But then the number of requests per second we were getting on that machine was so high that just one core could not handle all that. So we had to increase that. I mean, of course, 99% of the time you never ever have to know about that. But that 1% of the time, it's better when you do rather than you don't, and then you have no idea where to start looking at where the problem could be. So yeah, I think
So what is the hardware budget for Grammarly? I mean, do you guys get like 20 euro per month, so you have to squeeze all the performance out of every machine, or these days everything is cloud, and like, oh sure, I'm gonna throw it onto Lambda functionality. I don't care anymore. And
yeah, actually, that's a valid point as well. I've talked about that on the Clojure exchange in my talk. So that it is all cloud nowadays, and especially if the problem you are dealing with is like embarrassingly parallel and there is no shared state. So why not just spin a few extra machines and just be done with it? And I already said that I think that it's I have a conspiracy theory that's a lie spread by Amazon and Google Cloud and all those other cloud providers, so that people will buy more cloud for them. But in reality, at least in my practice, there is no such thing as horizontal scaling, and at least effortless horizontal scaling. So you're always like paying with something. So it could be operational overhead. So you have to spin up new infrastructure to deal with those extra machines. Or suddenly, it's like you thought you already solved the problem of monitoring. You have a graphite cluster for your 25 machines, but then suddenly when there are 100 machines, your graphite cluster cannot deal with that. So all of your dashboards take like 10 minutes to load, and your deployments are now, they take 2 hours to completely deploy. And if you botch a release, then it will, like, you will know only in 10 minutes that something is wrong because your monitoring system is not good enough.
Delayed by 10
Yeah,
minutes.
but then it's like already how the deploy is done, and you have to roll it back, and it takes another hour. So it gets quite painful, actually. And
Yeah.
on top of it, you hire more people to deal with that. You hire DevOps and infrastructure staff, those kind of people, and it costs even more money than just the extra machines that you're running. So I mean, I think it still makes sense to optimize just even for the number of machines that you need for the service, because it's never free. In terms of money, in terms of mental health, all those things.
I remember when I was working at Toyota, they have a thing, like a Japanese phrase in the manufacturing called heijonka, and what that means is evenness, so smoothness. So to your point about, like, if you're not careful with all these edge systems, they become swamped. So the idea is that you always try and across the entire system, promote a kind of holistic evenness, so that you are always emphasizing smooth throughput rather than one specific process which is kind of going a lot faster. Because then you find that if if the front end process is going very fast, then all the back end systems start to get overwhelmed. So it's an interesting architectural thought, that I think, as to how you do all the buffering at the right places and the throughputs, and so I think that's a general nice bit of advice to emphasize smoothness across your entire system, not just, or performance across your entire system, not just one piece.
Yeah, makes sense. So I think our friend of the show, Mr. Zach Oakes, is asking about good old days of Clojure on Android.
Yeah, right. Hi, Zach.
So
yeah, I think it's 7 years ago now when I started participating in Google Summer of Code, working on Clojure on Android, actually, and that started with my first mentor was Daniel Solano Gomez, who is an amazing guy, and I think he still contributes to the Google Summer of Code things on the Clojure part. At least he did a few years back. And then my second mentor was Zach Oakes, and back in the days, I think he was a sole user of of the things I developed. So it made sense for me to pick him as a mentor. But yeah, it was a fun project. I kept it going for years, and it was quite entertaining and fun as well. I was super hyped to have a running REPL on Android. And I developed a couple of apps that way, and it was like completely different experience from what Android tool chain offered back in the days. And I think they still have nothing like that. I'm pretty sure they don't. But yeah, unfortunately, I stopped working on Android platform for different reasons. So those projects kind of died out. But it was fun to do that back then.
Yeah, I noticed actually I can't remember his name now, unfortunately. I think it's Dimitri someone. Just the past couple of days on the Twitter feed said he's porting Replete, which is the Mike Fikes iOS REPL for iOS. He's porting it to Android, and he's got a few screenshots. So it seems like the REPL for Android is coming back.
Yeah.
So timely memory there. Yeah.
Yeah, so I think you can still download the Clojure app for Android from the Play Market, and
all right,
yeah, I did that, and it's like complete Clojure inside. So there is Clojure compiler inside, so you can solve Clojure tasks from your Android even without the network or anything. It runs on the phone itself, and yeah, a fun way to spend time on the subway or somewhere.
Did you do any performance analysis on that one?
You think you're joking, but actually 2 years of Google Summer of Code, I actually spent more not on the Android but on the optimizing Clojure compiler that would produce the code that would have faster load time and would be slightly faster at runtime as well. I also kind of that project is in slumber as well, also for different reasons. But it was also quite fun to investigate that to get why Clojure gets to start so slowly. And I still think there are things to be done in that regard. Just needs some time and effort.
So are there any like a rule of thumbs for people writing Clojure to make sure that it will still continue going fast?
Yeah, well, as with everything in performance, the first rule of thumb is to use the profiler to see like where the biggest problem is at, because the intuition is quite often wrong in that regard. You might be thinking that this part of code is to blame, and you can spend like 2 days just micro optimizing it, getting the most of it, but then it was in some other place all along. So the first thing is to use the profiler, and then that would tell you, most of the time, that would tell you a lot about what you have to do. But then, of course, there are different things that could go wrong in the Clojure program in terms of performance. There is the reflection that you probably didn't want to invoke or to go into, or the immutability of the data structures that you're using in that particular case that could get in the way, or there is stuff with math, with boxed math, that is very close to reflection in that regard. But yeah, profiler will get you half of the way to solving the problem.
So before we move on to the next topic, so how do you handle with all there is a lot of discussion about Clojure 110 and specs and error messages and all that stuff. So what is your opinion on current state of error messages that are coming up in 110? I think there is significant improvements made already, or do you think it is still debatable?
Yeah, well, I can tell you that it's certainly better than 1.9. That's for sure with the introduction of spec. I mean, I never had the problem with Clojure error messages. Actually, it's like it took me a bit to get used to them, and then it's like you just visually do the pattern matching. It's like, okay, the long cannot be cast to IFN. Okay, then means I try to call the number or something. So it's not ideal, but then it wasn't a problem for me. And with 1.9, all the specs blowing out in your face, that became a bit of a problem. More like mild annoyance or something. Something already said that on your podcast, that they just stopped reading the error messages with 1.9. It's like, okay, something is broken. Computer told me something is broken. I gotta go figure out what it is. And 1.9 puts that back into the 1.10. Sorry, puts that back into place. I'm happy about that, at least.
Yeah, nice. So I think we are almost 1 hour almost, or maybe over 1 hour. We were just thinking, because this is going to be our last episode for this year. I don't even remember when we started this. Maybe 2 years ago, or maybe I think so. It's been too long.
43 episodes. So
43 episodes, yeah. So more or less 1.5 episode per month. So I think it's it's a nice time to wrap up the year by reflecting on what happened in Clojure for 2018. So Alex, do you want to talk about how was Clojure for 2018?
Yeah, for me it was certainly good. It was a good year for me in terms of using Clojure and just observing the new cool stuff that came out from different people. And one of the major things is, you already mentioned, the error messages. I'm happy not as much about the messages themselves, but that Cognitact showed that sorry, they showed that demonstrated that it's really something that matters to them, and they listen to the community opinion as as much as they can. And actually, another big thing that you already sure know that happened, these debates on Twitter, then never ending ones that some point was troublesome to just keep up with them. You open the Twitter and you see another one, and it was quite painful. Yeah, but I think I'm happy that it came to an end, at least in my Twitter feed. Maybe I just unfollowed enough people, so that it ended.
Yeah.
Yeah, but it ended, and I think people made the correct conclusions out of it, and we got a few bigger explanations from Rich Hickey and from Tim Baldrige as well. I think Doug Talman also wrote a bit. So I think people in general won. I mean, it's like the things you can read now and you can understand it better. So everything got better from it, I hope. I think that's an important thing that happened in 2018.
Nice. And Ray, recap of 2018.
Yeah, well, I'd agree with a lot of everything that Alex said there. And I think that for me, my highlights were like definitely the conferences. I didn't get to the American conferences, but I went to the Clojure days in Amsterdam, and that was really excellent. Some great speakers and just a great community again. Just lovely people, lots of ideas, lots of positivity. And then myself and Alex met again at the Clojure X in London, which is also a superb conference. Shout out to John who organizes that. They do a great job there. It's a great fun, very entertaining, lovely venue. The people at Skills Matter do a great job. So yeah, it was really nice, and it was nice to see at the end of that conference that Christophe Grand and Bojidir, who was the most miserable person on our podcast ever, actually were celebrating with a beer about the joining of NREPL and UnREPL. So the NREPL, the back end REPL wars were seeming like calming down as well. So that was good. So I think basically the community for me, I really enjoyed some of the bullshit on the flame wars were annoying, but overall I think the community has been really good this year, coming out with some great ideas and some great tools and some great stuff around documentation, Maria Cloud, these kind of like tools that are gradually coming out around spec as well to make that more consumable. That's all good. I myself have started to make this collaborative REPL for, so I've become a kind of like tooling guy as well now. So that's been a fun time, and I'm working full time with Clojure. So it's great to be doing it full time and as a hobby. So, I've just been loving it really. Yeah. How about you, Vijay?
Yeah, I think obviously, as you said, the conferences were super fun. That's where you get to talk to the community. And obviously, Alex was there at Dutch Clojure Day, opening the conference with a fantastic talk.
Yeah.
And Clojure D in Berlin, super fun. And I think there are some the whole discussion on Twitter, and then the whole people complaining about the community and all that stuff. And I think right before the show, we were just I was just chatting with Alex that like when people are complaining about it, that means we have like grown a lot. It's like that means we became mainstream, which is pretty awesome. The more people complain, that means the bigger we are. So, but in general, I think it's been a fantastic community, and of course, I'm doing a lot of Clojure stuff as well for a NDA, something that I can't disclose. And then, of course, we have Dutch Clojure Day coming up for the next year as well. We just tweeted out, hey, we want to organize the conference, and then people are reaching out to say that, hey, we want to sponsor, which is pretty amazing.
Excellent.
And we have 150 spots, and we almost are like 90 free tickets are gone already. So that means there is a lot of pressure on us to run it. And from the language-wise, I think a couple of things from Conj was really fun with the Rebel, the new thing, and the datafying stuff, which is super cool.
Yeah.
I'm a bit. I think it's too much used to the open source shit. So every time I see something that is we only have GitHub for issues. That's a bit of a uh, uh, kind of a strange thing to hear, because so many years of working in open source with JBoss tools and all that stuff, and suddenly hear something that there is a tool that is available, but it's not open source.
Yeah, it's unconventional.
Yeah, exactly. But hey, we use Clojure and nobody complains whether it is open source or not. So
Well,
but otherwise, I think
GitHub
it's
isn't
been-
open source, that's for sure.
yeah, exactly. and Jira and all the shit that we use day in and day
Yeah.
out. But it's been I think it's a fantastic year, and I'm looking forward to next year. What we are going to, what the community is going to bring out, and most recently, if you see the amount of people who are doing the advent of code in Clojure, with people sharing their knowledge and everything, that shows that there is a lot of happy people trying to learn Clojure, trying to do amazing things with Clojure. So that's 2018 for me, and I hope we'll continue doing this podcast. And of course, shout out to the 2 new podcasts, the REPL by Daniel.
Compton, yeah. It's really good, that one.
Yeah, and also the Functional Programming with Clojure podcast or something that I retweeted at some point. So there is a lot of, we are growing. So this is a nice nice community to be in, I think. It's a fantastic year.
Watch out, maybe those are also Clojure vegan podcasts, and you will not be number one anymore.
No, I don't think we're not aiming for number 1. It's okay.
No. We are I think we are like the we'll acquire them eventually.
Yeah.
Well,
I think we're still the number 1 vegetarian Clojure podcast. Yeah. So.
And I think we are probably the only R-rated Clojure podcast with amount of fucks and shits in the same episode. I think that cannot be beaten anyway. So
Merry fucking Christmas.
Happy holidays. So that's it from us for this year, I think. So we'll be back next year. And thanks a lot for joining, Alex, taking time from your, I guess it's not Christmas holiday yet there.
Yeah, but it's getting closer.
Yeah. And you have a new church now or something like that, or in Ukraine?
And you what?
They're forming a new church in Ukraine. Anyway, that's probably
Let's talk about that afterwards.
That one. Yeah, but thanks for having me. It was very glad to be here.
Yeah.
It was a pleasure. Yeah.
I just say that you're wearing a Christmassy jumper, which is you can't hear on the podcast, but YouTubers
I
enjoy
have
that.
Snowflakes and all.
Exactly.
So
very Clojure.
I'm in the right mood. Yeah.
Perfect.
I just want to say the last few words. So regarding the flavors and stuff, I think just to offer a counter opinion, I think we should cherish and protect and respect our open source maintainers. So at least for the fact that Clojure has been maintained for 11 years straight by a small bunch of individuals, not backed by any corporation or something, and just doing that without burning out, and just wanted to keep doing that. I think that's at least a thing to respect them for and to support them for. So that's what I plan to do the next year and years to come, and encourage everyone to do that as well.
Well said.
Awesome.
Well said.
Awesome.
Yeah.
Yes. So that's it from us for this this year, episode number 43 with Alexander Yakushev, and we'll see you everyone in January, I hope.
Yes.
Yeah. Bye.
Bye.